Hello everyone, my name is Sharath. My topic for today is edge intelligence and human augmentation and their key ingredients. First of all, thanks for giving me the opportunity to connect today and giving me a chance to discuss this topic on my perspective. Next, then introduction to edge intelligence. Edge intelligence and AI, human augmentation are two major technology trends driven by recent advancements in the edge computing, IoT, and AI accelerators. First, the increase in data availability, consolidated computing power, and the advancement of machine learning techniques has fostered the development of AI-supported applications, and that continue to transform virtually every aspect of our daily life. Second, the increasing of internet-connected resources and intelligent things embedded in our surroundings like Amazon Alexa or Google Home, and wearable smart devices like Apple Watch generate a wealth of opportunities to create many applications that can enhance our everyday experience and quality of life. Third, the growing friction between cloud-based AI solutions and the need for many applications to analyze high volumes and high velocity data streams in near real time has pushed hardware developers to create miniaturized AI accelerators that promise to bring AI to the extreme edge. Even though edge intelligence helps in situations, but there are legitimate concerns about the privacy and trust, particularly as we become more dependent on AI. Furthermore, as we move towards artificial general intelligence and strong AI, isolated AI programs will become increasingly interconnected and began to solve increasingly complex tasks collaboratively. In this paradigm of edge intelligence, where a cyber physical fabric provides raw data and can intelligently act on it, edge computing is faced with some unique challenges from the AI system problem space. In this paper, the edge intelligence mainly discusses two things. First, we discuss the underlying infrastructure and coordination mechanisms required for the edge intelligence, and second, we discuss operational edge intelligence, enabling end-to-end platforms and workflows to manage edge AI application lifecycle. The development of AI has taken spectacular leaps over the past decade. The number of internet-connected sensors, devices, and autonomous agents that can sense and manipulate our physical surroundings continues to grow as we move forward in the AI or in the advanced future. And the evolution of man was defined in different manner before, but now the evolution of human has been divided into 4 steps. The first step of the cyberhuman is about the regular use of phone, like the speech and messaging, which we started in the beginning, and now it has been moved to the use of speech, camera, and the step 2 is the use of speech, camera, and smartphone sensors. Third is transparently immersive experience like VR, like we are looking for VR, virtual reality, and expecting to be everything in the same place from the where you are and experience the situation. Fourth one is the step 4 is main important, which are going to be the fundamentally the challenging of our building of systems. So as the edge intelligence grows or the VR grows, there for sure there will be a fundamental challenging way on how to look and how to build our systems as well. As part of the as part of the edge intelligence, smart cities smart cities are the best examples, and building of smart cities is the best example where smart cities provide several exciting opportunities for edge computing. We believe that edge intelligence will be the key to connect the cyber physical and their inhabitants. Not everyone has the same, even though we are planning to build the security, but not everyone has same access to the data and ML capabilities to train effective models from scratch. However, suppose someone wants to create an application that combines face recognition, emotion interpretation, and a conversion system. In that case, they could use of off-the-shelf models and refine them to their domain-specific data, which results in democratizing of the AI, which helps in creating tentative results and can be used in implementation of system or an application. Now coming to the next slide, the key ingredients of edge intelligence. We identified 2 orthogonal elements that play key roles in realizing edge intelligence systems from our discussion and the presented use cases. First one is the main parts are the computational fabric. Computational fabric dispersed resources will allow the training, monitoring, and serving of models. The heterogeneity of applications and models will require flexibility and modular infrastructure. And operationalization is something like how these can be operated and how automation of AI application lifecycle management will have to move beyond the current predominant cloud-based view. And going more details of the taxonomy or my key ingredients of edge intelligence. The first one is about the computational fabric. Sensing substrate and sensing data. A large number of dynamic and mobile nature of both publishers and subscribers increase our requirement to use of Amazon IoT or Microsoft Azure IoT. The main challenge is providing scalable access to a vast amount of data. The next one is modular AI capabilities. The same type of GPUs in the clusters may not be feasible because of the edge resources, sizes, and the power. The heterogeneity of the edge platforms and algorithm increases proportionally as a function of a service model. The third one is multi-purpose self-adaptive edge computers. For efficient use, hardware needs to be grouped into cohesive units of multi-purpose edge computers. Learning trade-offs between edge, energy efficiency and latency and forming the infrastructure unit of edge computing is the main purpose of adopting the use of self-adaptive edge computers. Now, the fourth one is about the edge coordination. This introduces new challenges for operational researchers. As VMs, as we know, virtual requirements requires a lot of resources, and not all edge computers are predominant form of isolation for edge computing. Most pressing operations for edge intelligence are three types. One is the multi-tenancy, intelligent scheduling, and proximity and mobile awareness. Next, the other side is six component. There are six critical components for operational edge intelligence. The first one is operations for AI. A variety of DevOps methods manage software cycle over a while. Efforts for AI lifecycle management are focused on both the training and deployment and will largely neglect the runtime in monitoring them. The four AI operations have different data model characteristics and various enabling techniques. Next, the edge intelligence operation. Systems like IBM AI use a cloud-based cluster deep learning infrastructure to operate on data processing cloud. Objects models are deployed as web services and edge resources as integrated into process. The workflow may be helpful for applications where training data is massively distributed into various lifecycle flows. And these are divided into four types like cloud to cloud, cloud to edge, edge to edge, edge to cloud, and complex hierarchical models as well. The fourth one is scalable provisioning. In general, resources poses several challenges for provisioning software systems and mainly AI applications. Edge resources must include different goals and constraints because proximity to data producers and consumers play a critical role in edge computing to maintain privacy and trust and enable low latency data processing. And if we take into consideration that the edge AI fabric will be used for both building and serving models, operational challenges are of two types. One is provisioning resources for AI pipelines at the edge, and the management of deployed AI applications at the edge. Next, scalable monitoring. Scalable monitoring, runtime monitoring of ML model metrics is fundamental. Deployed models are subject to degrading performance caused by the concept drift. Many models may introduce series of large user base that require personal model that is transferred learned from base model monitoring. Privacy. Personal data spaces are the dominant form of achieving privacy-aware data distribution. Access controls will be in complete control of their personal and sensitive data. Explainability. The last one is explainability. Explainability AI continues to dominate other areas of human life, and questions of bias, ethics, trust, and safety has become more pressing. A reasonable approach for cloud-based workflows where storage can be easily scaled, but many prove much more challenging in edge computing, where data is decentralized and stored generally. As edge AI systems grow more complex and the development of AI becomes more and more fast-paced, researchers will be challenged to devise methods for XIA that became an integral part of AI systems. Coming to the conclusion, the increasing interconnectedness of human beings in the fast-paced development of edge AI methods and hardware. That's what we discussed more. And full end-to-end realization of intelligence, scale, edge intelligence, and many questions require further investigation, mainly concerning the ownership. We observe three categories of edge intelligence use cases in different cases, like the public, such as intelligent public spaces; private, personally unclear who will own the future fabric for edge intelligence; and utility-based offerings for edge computing will take over, as in the case of cloud computing. For the full end-to-end as the case of realization, sorry. And final, these are the topics of these are the papers that I've used to build this analysis, and thanks for giving me this opportunity.